Hello everybody. Thank you for joining me once again as we continue looking at the 2002 Cayley competition. We're on question number 20, which says, two cylindrical tanks sit side by side on a level surface. The first tank has a radius of 4 meters and a height of 10 meters and is full of water. So they're cylindrical, and we know the radius and the height. I can tell you, using the formulas, and these are the sorts of things you should be thinking about. These sorts of things should pop into your head. You should be thinking about the formula for the volume of a cylinder. You should be able to, well, I know I can, but you should also be able at this point to tell me how much water is in here, the volume of water that's in there. The second tank has a radius of 6 meters and a height of 8 meters and is empty. So we could figure out the volume that this second tank contains. It doesn't contain water. Right now it's empty, so I guess it contains air. But we still have the radius and the height, and that is enough to figure out the volume of the cylindrical tank. Water is pumped from the first tank, the one that's full of water, to the second until the depth of the water in both tanks is the same. So not the volume of water, but the depth of the water, the height of the water in both tanks is the same. The depth of the water in each tank in meters is... and then we have our options. So let's jump straight to our notepad and draw out a picture of what's going on. So we start off with two cylinders. They don't quite have the same dimensions. I think one was a radius of 4 and a height of 10. I'll check all this in a moment. And the other one was a radius of 6 and a height of 8. And we start with this one over here, just full of water. And then water is pumped and poured into the other tank until not the volume of water, but the height of the water is the same. So what we'll get is the water's up to here and up to here in both tanks. So the water hasn't exactly evenly been split, but they both have the same depth or height. I'm going to call it H. Actually, no, let's call it D for depth, just because that's the term they're using. Okay, so let's just double check the dimensions of our cylinder. Radius of 4, height of 10, and then a radius of 6, height of 8. Good, I got them right the first time. Okay. So water has only been transferred around. It hasn't been lost. It hasn't been gained. And so that gives me the key to solving this problem. As I mentioned before, we can, using this information of radius of 4, height of 10, figure out how much water is in this first tank. Well, that water is going to be split over these two tanks. And we should be able to get a formula for that volume in terms of D, set it equal to the known value, and we'll be all set. So we have to remember the formula for volume of a cylinder. So a cylinder of height H, this is why I changed it from H, I didn't want to get confused. So the answer I'm looking for is D. So we have a height of H and a radius of R. It's pi r squared, the formula for a circle. And then we sort of have circles all the way down, so we get an H there as well. So this is the formula for volume of a cylinder. So the volume of water, which stays the same throughout the whole question, is going to be pi r squared, that's going to be a 4, times 10, and that becomes 16 times 10, 160 pi. And if we had to have units, meters cubed, although I don't really think that matters too much. So that's how much water there is in total in the whole question. Now, in this in our end scenario, where the water has the same depth in both tanks, we've got two formulas we're going to need to use. One with a radius of 4 and one with a radius 6. And if we can figure out these two cylinders of water and add them together, we should be okay. So water in first tank plus water in the second tank, well, that's pi. We're going to have another 4 squared here times d, the depth of the water, plus pi, now it's 6 squared, times d, the depth of the water. And I can take out a pi and a d, so I'll get 16 plus 36 pi d. And I know that that's going to be equal to 160 pi. So first things first, I can divide through by pi on both sides. And I can rearrange and say 160 over 16 plus 36 must be equal to d. Just rearrange this equation here. So now the question becomes, what's 160 over 16 plus 36? Well, what's 16 plus 36? That's going to be 46 plus 6, so that's 52. So 160 over 52. Now I notice both of these have factors of 4. So I'll take out a 4 from the bottom. I get 52, or 52 divided by 4 is 13. And taking out a 4 from the top, I get 40. And looking at that, 13 is prime, so I can't reduce it any further. So this is my final answer. And I think I saw some fractions here. There it is, it's E, 40 over 13 meters. Alright, so that wraps up B part on the 2002 Cayley. In the next video, we're going to start off with part C by tackling question number 21. So thank you guys for joining me for this video, and I hope to see you in the next one.